Hey guys, so this week we are doubling up on tectonic plates because it's a bigger subject. This is a little illustration that I created for y'all, kind of to make it a little easier. When we're talking about tectonic plates, we're going to be talking about 3 different types of boundaries that we have. And boundaries are just when plates are coming together, going away, or rubbing against each other, okay? So here's a quick little explanation. You have something called convergent boundaries, and those are boundaries or plates that are going to collide and push into each other. The next one is divergent boundaries. They move away from each other. They're separating. And then the last one is transform boundaries, which slide in opposite directions of each other as they're like coming together and like rubbing against each other and just causing earthquakes and all that geological event. So there's that. And then your assignment this week is to read from the STEMscopedia book. You're going to be starting on page 93. And then you go through page 94, 95, 96, 97. The last little part for reading is on page 98. And you'll notice you have another little table of characteristics of tectonic plates. It's going to be kind of like when you did the layers of Earth for that Venn diagram. And you're going to do it this time for tectonic plates, okay? There's 3 main circles. You have those 3 types of boundaries: convergent, divergent, and transform boundaries. And then obviously you have the little parts of the circle where they're similar between 2 circles, or if they're similar between all 3, that's where you put it right there, okay? So you're going to take these characteristics, those exact ones right there, and then put them in the circle. And once you have done that, you're going to take a picture and send it to me through my email, okay? Okay, last part. I know I promised y'all a little treat, so let me get, y'all are gonna look at the tree. Well, here we go. Okay, so here's the last little part. As you can see, I have some graham crackers and I have peanut butter on one of them, okay? So this is gonna be a little illustration that represents plate tectonics. Your peanut butter is actually going to represent the mantle, and it's something that we call plasticity. And you'll notice that when you read about the mantle in your book this week, you'll learn about the term plasticity because it's something that's solid, but it acts kind of like a liquid. It's still movable, okay? It's kind of like slime and putty and Play-Doh and all that stuff. So this is a fun little treat that you can make. If you want to make it for your little sibling, that's fine, or you can eat it yourself. You're going to break apart the little parts to represent your plates. I'm going to put one on one half and one on the other half. I'm going to move my bigger plate out of the way. We don't need that, okay? So now we have 2 plates together, okay? Sorry, I'm going to try and like, how am I going to do this? Okay, so I'm just going to do it with one hand. It's probably going to be a big fail. I'm sorry. It's all good. So you are going to show me the 3 different types of boundaries with your graham cracker illustration, okay? So obviously, if you have plates moving away from each other, that's going to be called what? Divergent boundaries. Good job. Okay. And you can see that that part of the mantle, it can come upward with the pressure of the plates moving away and moving downward. So maybe that's like magma coming from deep within the earth. And then our next one is if they're coming together. Look at that. Some of the magma is starting to rise up in there. And if y'all remember, when magma cools, it creates igneous rock, which is solidified magma, okay? And that eventually will help create mountains and all those big landforms, okay? So it's coming together, it's converging, right? The very last one, you are going to have them move away from each other. And if I had two hands, this would be a little better. But if you add a little pressure to it, you'll notice that some of the magma is coming up, and then sometimes little pieces of graham cracker will break apart. And that's due to all that pressure from them sliding past each other. Okay? And like I mentioned last video, a lot of places that have transforming boundaries or plates that are rubbing up against each other, they get earthquakes because there's a lot of pressure and tension being built up in there, and it causes some instability in the plates. Okay? So, if they're moving away, diverging. If they're moving together, converging. It's starting to get messy. If they're moving or rubbing against each other side by side, oh, I felt a little break in the graham cracker. That is that is transforming, and that causes earthquakes, okay? So that's a little messy, but you get to eat it afterwards, and you can impress your little siblings if you want to, have a little mini lesson with them, okay? So just remember, your only assignment this week is to do your Venn diagram, take a picture, and send it to me. And then if you happen to do the graham cracker peanut butter example, you could always take a picture of that and send it to me. I do have a little hint. Marshmallow fluff works a little better than peanut butter. So if you have marshmallow fluff, that'd be even better, okay? Y'all have a good week. Stay safe. Be healthy. I miss you guys. Bye.